Welcome to the demo and tutorial video for the CUBIST prototype. CUBIST, which stands for Combining and Uniting Business Intelligence and Semantic Technologies, is a research project funded by the European Commission and carried out by 7 partners from different European countries. In a nutshell, the project aims at developing an approach for semantic and user-friendly business intelligence by augmenting semantic technologies with BI capabilities and providing conceptually relevant and user-friendly visual analytics. A main activity in CUBIST is the joint development of a prototype, which is shown in this video. This prototype does not only support the analysis of data, it supports different means to access information. That is, with CUBIST, it is possible to conduct factual search. If the user has a precise information need, she can search for specific entities and facts in the information space. Also, it is possible to explore the information space. If the user has an imprecise information need, she can navigate through the information space. Finally, it is possible to apply visual analytics. The user can define sets of entities and related attributes, and then interactive diagrams depict those sets. 3 partners in the CUBIST consortium are use case partners, and they provide quite different use cases which showcase the prototype. The Heriot-Watt University use case deals with biological data and focuses on the analysis of gene expression in mouse embryos. The Space Application Services use case focuses on the analysis of log files of technical equipment in space, for example, on satellites. Finally, in the Innovantage use case, analysis of the online recruitment activities of UK companies is conducted. For each of these use cases, the prototype has been customized. In the following, we will use all 3 use cases to show the capabilities of the prototype. As you have seen from the last screenshots, the look and feel of the 3 different use case prototypes is distinct, but the structure and functionality is the same for all 3 use cases. We start our demonstration with the Heriot-Watt University use case. The prototype contains different panels or pages, each of them dedicated to a specific task. At the top of the prototype, you find the navigation bar. The active panel is marked in bold. We are currently in the Search and Select panel. From this panel, we can move to the Visual Analytics panel or to the Graph Exploration panel by clicking on the buttons. Additionally, we have a Home button which brings us back to the Start page and a Help button. On the left-hand side, we find some facets for the different data types in our respective use case. The Heriot-Watt University use case deals with the analysis of gene expression in mouse embryos. Thus, gene is one type of interest. Let us have a closer look. If we click on the radio button for gene and then click refresh, the first 10 genes in our data set are shown. The paging function allows us to walk through the whole list. Details for a gene are shown when the label of the gene is clicked. Some of the details, like the gene's synonyms, are literal values, whereas other details, like in-textual annotation, refer to entities of different types. As we see, the selected gene appears in at least 5 textual annotations. The list of all textual annotations is shown when the label in textual annotation is clicked. Again, we have a paging function and details for each textual annotation can be shown. Note that the panel has changed. We are now in a panel called Instance View, but we can go back to our original Search and Select panel. We can navigate through the information space between different entities using their semantic relationships. For example, we can display the tissue which is part of the first textual annotation. Then look at the tiler stage to which the tissue belongs, and look at a list of the other tissues at that tiler stage. As we have seen, we can explore the information space by navigating along semantic relationships. We can go back to our initial Search and Select view by clicking on the corresponding tab. We return to the list of genes. We have seen that entities have different attributes. For a given type, the list of attributes is shown when the label of the attribute is clicked. It is possible to search the list of attributes. This shall be demonstrated in the Space Application Services use case. Here we have only one type, named packet, but nearly 200 attributes. There is a search box on the top of the attribute list. This search box can be used to display only a subset of the attributes. For example, we can show only those attributes which contain the string time. For an attribute, the list of all attribute values is shown when the label of the attribute is clicked. It is possible to search the list of attribute values. For performance reasons, the list is only updated when return is pressed. We now search for genes where the label includes B, M, P. We can select some of the genes with the checkboxes on the left. These checkboxes filter the displayed data. If we now press refresh, only those genes with the selected labels are shown. We can add constraints using attributes of a different type. For example, we can display only those genes which are strongly expressed. In tissues, from tiler stage 10. When filter conditions are used, CUBIST uses the semantic relationships between entities of different types in order to retrieve the desired results. In our list of selected genes, only BMP2 and BMP7 are strongly expressed in tiler stage 10. So far, we have seen how checkboxes can be used to filter the displayed data. Checkboxes are used for string-like attributes. For numerical or date-time attributes, we can define intervals of values to filter the data. This shall be demonstrated using the Space Application Services use case. In this use case, we investigate a log file from a solar instrument. In our dataset from October 2008, this instrument has recorded a set of roughly 200 parameters every second. Let us assume we want to investigate the first minute of the log file. The start point of this first minute is the first instance of the parameter has time. We set this as the minimum value by pressing the minus button. Note that the min value has changed accordingly. We can directly add conditions in these fields too. Instead of scrolling through the values of has time, we can simply add the first entry as max with the plus button and change it afterwards manually. In order to activate this min-max condition as a filter, we press Add. Just like checkboxes, it is possible to select more than one attribute value. In this case, we could add multiple intervals to the filter. If we click Refresh, we see only the data generated during the selected interval. We can look at the details for each log entry. That is, by clicking on a log entry, we can inspect all 200 parameters. If we are only interested in a few parameters and wish to compare values between log entries, the data table view is useful. Let us assume we are interested in two SOVIM temperature parameters. These parameters are selected with the checkboxes on their right. If we now select the data table view, we see the selected objects as well as the selected attributes. We have seen how we can inspect types, their attributes, the values of those attributes, and how we can use the filtering option for attribute values. As the name suggests, the Search and Select panel serves two purposes. On the one hand, it can be used to conduct a factual search for specific entities. On the other hand, it can be used to select a set of entities which can either be explored with the Graph Exploration view or on which visual analytics can be applied. These two mechanisms will be shown next, starting with the Graph Exploration view. In the Graph Exploration view, we can explore a network of different types of entities in an interactive graph-based manner. We are interested in tissues from Tyler Stage 6, so we select tissue as the type of interest and filter it down to tissues from Tyler Stage 6. Now we enter the Graph Exploration view. We see a graph where the nodes depict the selected tissues. If we click on one node, we see its attributes and the semantic relationships to other entities. We see that the tissue is involved in two textual annotations. These can be added to the graph one by one using the green plus buttons. For a given node, if we want to add all related entities at once, we can use the plus sign at the node. Finally, we can add one particular semantic relationship to all appropriate nodes with expand relations. For example, let us add the related textual annotations to all tissue nodes. To expand the network further, we now add all genes that appear in one of the textual annotations. By doing so, the network might become too big. With the range slider, it is possible to focus on only the neighbourhood of a selected node. Or, with the red minus button, we can remove all the neighbourhood nodes and then the node itself. To summarise, the graph exploration view provides another way to explore the information space. Let us now consider the visual analytics capabilities of CUBIST. Although we will demonstrate a number of features, it will not be a full overview of the functionality. Our aim is to analyse genes and the tissues in which those genes are detected, or strongly detected, restricted to tissues from Tyler stages 6 to 8. So we select genes as objects of interest, the labels of tissues and the names of Tyler stages as attributes, and we add constraints for the Tyler stage and the strength. The data table shows the data to be analysed. Let us enter the visual analytics. What we see here is the concept lattice of our selected data. The nodes depict so-called formal concepts. The formal concepts are clusters of genes which we have selected as objects of interest, and both tissues and Tyler stages which we added as attributes of interest. Hovering over a node shows, in a tooltip, the objects and attributes of the concept. For each concept, all the attributes of the concept apply to all the objects of the concept. For example, we see that the genes ETV5 and SMAD2 are detected in the tissue called embryo TSO7, which belongs to Tyler stage 7, which is called implantation and formation of egg cylinder. Moreover, we see that the node is placed above the node labelled SMAD2. The higher a node is, the more objects, but fewer attributes it contains. That is, the gene SMAD2 is detected in all tissues where ETV5 has been detected and in some extra tissues. The lattice diagram is linked to more visualizations. On the right-hand side, we see for a given concept the distribution of all attributes that apply to some objects of the concept. This can be best seen with the top node, which contains all objects. Thus we get the distribution of all attributes to all objects. It is possible to add or remove both attribute and object labels from the diagram. Sometimes the concept lattice is too complex. We can filter the displayed information further in order to reduce the complexity of the lattice. This can be done with the filter panel. We see on the left the distribution of the selected 3 Tyler stages, and on the right the distribution of the tissues. Clicking on one of the attribute pie charts restricts the set of displayed concepts. For example, we can click on the pie for Tyler stage 8, called differentiation of egg cylinder. Note that the displayed lattice at the top, as well as the pie chart for the tissues, has changed. We can drill down even further, for example, by selecting the tissue embryo TSO8 in the right pie chart. We can undo our filtering with the Reset button and have another look at the diagrams on the right-hand side. They provide additional means to explore the data. We will now demonstrate the Co-occurrence tab. In this tab, you can select 2 sets of attributes, and a diagram shows how many objects, in this case genes, are shared by the 2 attributes. We demonstrate this with Tyler stages. For Tyler stage 6, namely attachment of blastocyst, we see that we have exactly 1 gene for that Tyler stage that is detected in the other 2 stages as well. Additionally, this can be seen in the lattice. The node labelled with attachment of blastocyst has only 1 gene associated, FGF4. And the node is below the nodes for the other 2 Tyler stages. For Tyler stage 7, implantation and formation of egg cylinder, we see that there are 8 genes detected, and 4 of them are detected in Tyler stage 8, differentiation of egg cylinder. Again, this can be seen in the lattice. Here is the node for Tyler stage 7, which contains 8 genes. And here is the upmost node, below the nodes for both Tyler stage 7 and Tyler stage 8. Thus, this is the node which represents the genes which are detected in both stages. We see that this node contains 4 shared genes. In CUBIST, different metrics are implemented. They can be used to either enhance the appearance of the diagrams or for additional filtering options. These metrics have to be pre-computed, and this is what we are doing now. The metrics can be used to customize the diagram. We choose Edges, Similarity. Now the more similar two objects are, the thicker the edge between them. For the size of the nodes, we choose the metric Support Extent. So the bigger a node is, the more genes it contains. We can use the metrics for filtering too. For example, we can decide to show only nodes where the extent exceeds a given threshold. In this case, the extent is the number of genes. As we raise the threshold, small, then medium nodes disappear. Essentially, we want to focus on only the nodes in the upper part of the lattice. In addition to the Hass diagram we have been using, we also have a Sankey diagram. This roughly corresponds to the Hass diagram turned on its side. We read it horizontally, not vertically. CUBIST provides even more visualizations. The others are essentially visualizations of trees. In concept lattices, nodes may have several lower neighbours and several upper neighbours. For bigger lattices, this often leads to diagrams that are hard to read. By using a node several times, it is possible to turn the lattice into a tree. Before we see some of CUBIST's tree-based visualizations, please notice that we have 2 nodes below the topmost node. Below the first, we have 6 more nodes, and below the second, 4 more nodes. One node is shared. Here is the sunburst diagram that corresponds to the lattice. The circle in the middle is the former top node. This is the lower node with 4 children. And this is the node with 6 children. The shared node appears in the diagram twice because it has 2 upper neighbours. We can drill down in the sunburst diagram to focus on a lower part of the tree structure. We can also move back up the tree. We will not show this, but all the filtering options work for the sunburst and the other diagrams too. Next, we see a traditional tree visualization, which can be expanded and retracted. We have 2 more visualizations, namely a matrix visualization and an icicle visualization. We will not discuss either now. At the top of the page, we have two tabs, Lattice and Rules. So let's turn to the visualization of rules. Rules are statements of the form, if for an object this and that attributes apply, then this and that other attributes apply as well. For example, if a gene is detected in Tyler stage 17, it is detected in Tyler stage 18 too. Here, the rules are visualized in a matrix view. The left-hand side of the rules, called the antecedents, are violet. The right-hand side, called the consequence, are coloured yellow. We have several metrics for our rules. For example, confidence. The more objects violate a rule, the less confidence the rule has. Some rules apply to many objects, others to only a few objects. One might consider rules that apply to many objects more important. This is measured with premise support. If we are only interested in rules with a high confidence and a high premise support, we can use the scatter plot to filter the rules. Each dot corresponds to one rule. The position of this dot is determined by the confidence and premise support. So let's select the subset of rules we are interested in. Details for the first rule are shown when we mouse over the rule. In the matrix view, we have a row dedicated to each rule. We have another visualization where all rules are merged. This is the radial diagram. We can see that these two attributes are often the consequence of some rule. The attributes are Tyler stages 7 and 8. Recall that in the concept lattice, these were the two attributes of the two topmost nodes. So both the radial diagram and the lattice inform us that being expressed in Tyler stage 7 and being expressed in Tyler stage 8 are general attributes. To summarize, we have seen different visualizations for lattices and rules, additional diagrams like the co-occurrence of attributes, ways to enhance visualizations, and filtering options. CUBIST provides a comprehensive toolkit for visual analytics. Thank you for watching.